Alrighty, I think we're going to get started, and if people join us as we go, that'll be fine. Right, welcome to the GMM meeting for, what are we in, July now, hard to believe. So today's EIFS 101 Fundamentals Through Design and Construction presentation. Our presenter is going to be Dustin Knapp. He's a senior associate at WJE. And yeah, Justin, do you want to say anything about yourself?
No, I'll get into it when we start the presentation, but I'm just looking forward to speak with you guys. And I had a lot of fun at the golf outing last weekend.
Cool. So thank you so much to our sponsors. I know we have Jeff on from Evergreen. Always great to have you guys with us. Thank you so much. Only possible because of you. And we have a few events coming up, so I'm just going to go through those real quick. I think we have, yeah. All right, so we have the Design Awards coming up Friday, July 28th at 5:30, Aloha Tower Sunset Ballroom. And tickets are available for that online. That registration is open. DNA Hawaii also ready to go, August 25th. Not sure if registration's open for that yet, but it will be soon if it's not. And then the other one that we have coming up that we don't have a flyer up here for is a trivia night on August 10th at 5:30 p.m. It's going to be at the Doll Tile showroom on Nimitz Highway. It's sponsored by Doll Tile and Seal. There will be food and drinks and prizes for the winning team, so you should come out and join us. It'll be a fun night. And Dustin, I think I will turn this over to you so we can get going.
All right, thanks, Michelle. As we get started, as Michelle mentioned, my name is Dustin Knapp. I'm an architect with Janney Elstner here in Honolulu. I've been with WJE for over 13 years. And in that time, I've worked on several projects that have involved the EIFS. Those projects range from investigations to renovation and repair projects to new design. The objectives for this presentation, the goal of this presentation is for you to be able to, at the end of this presentation, to have a general understanding of different EIFS types, be able to provide information on the requirements, whether they're code-related requirements, and be able to reference the available literature that's out there, how to provide a general understanding for the development of specifications and detailed concepts, and then also how to recognize some common problematic conditions, whether it's design or installation, and then how they can be addressed. As we get into the presentation, if questions come up along the way, feel free to stop me and ask the question, or you can put it in the chat, or we can address it at the end of the presentation. So either way, but if something comes up, it's on your mind, feel free to reach out and I can address it right away. So first, we're going to get into it. EIFS stands for Exterior Insulation Finish System. The walk to run history of this is that stucco was developed in Europe in the 1930s, and then in the late 60s in the United States, the manufacturer Drive-It introduced the outsolation system, which included an insulation, a building insulation on the outside of the wall sheathing. The EIFS systems are supplied by a number of manufacturers, and it's a specific manufactured system. Something to know. On the left, you can see this isometric, which shows out the components of a typical EIFS system. You have your structural wall assembly, so the studs and the wall sheathing. On top of the wall sheathing, you have your water resistant barrier, your WRB, and from there you'll have your attachment methods, whether it's mechanical. This one shows adhesive ribbons, followed by our insulation board. This one is using an EPS insulation board. The base coat and mesh, it's fully encapsulated in the base coat, optional primer, and then a finish coat. The base coat, mesh, primer, and finish coat, those three together consist of the lamina, which we'll talk about in a little bit. So there's two general types of EIFS systems, one being a barrier system and one being a drainage system. The barrier system is a general architecture term, but it applies to the EIFS. This type of EIFS system is that it's a wall. It's a wall that's not supposed to let any water behind it. The lamina, so as we talked about, that base coat, mesh, and finish coat, is to be the drainage plane. No water is to get behind that. So all of the finish coat and all the lamina is supposed to be continuous, no cracks. The sealant joint and any flashings associated with the interface conditions are to be continuous and fully tied into the EIFS barrier system, because as a typical barrier system goes, if water gets behind the drainage plane, then it can become trapped within the system and then build up, and that can lead to some more significant issues. So you'll see here this isometric on the right. These blue arrows are just indicating where the drainage plane is. So water is to get to this level, just the face of this where you can see, and it's not supposed to get behind. So you'll see these yellow boards and these horizontal ribbons for water's not supposed to get back to this level. And we get to the drainage system where the EIFS is serving as a rain screen. So we have the lamina acts as the area, the drainage, or the area for the bulk water resistance. And then there's the WRB, so the water resistant barrier behind the EIFS, indicated by this line, that is intended to collect any residual water that gets through the EIFS system, combined with some flashings, and direct that water out of the system. So with a drainage system, it's okay if there's some deteriorated or failed sealants or potentially some cracks in the lamina that allows water to get through, because the drainage plane is behind that EIFS rain screen, and it'll still be evacuated out of the system. So just again, these blue arrows are showing where that, the EIFS lamina is, the bulk water resistance, and the red arrows indicating where the WRB is, the drainage plane. Going back to a barrier system, looking at the EIFS cladding on these single family dwellings, you'll notice there's no through wall flashings at window head conditions or at sill conditions. This is an indication that it's likely a barrier system. See here, there's no through wall flashings in any of these head or roof to wall interface conditions. The picture on the left, jumping back to a drainage section, shows a through wall flashing, this L-shaped through wall flashing. This is at a change in floor height where there's a deflection track. You'll see indicated by this little concave area here. And this yellow is the WRB, liquid applied WRB, that's lapped over the vertical leg of the through wall flashing. So this is the EIFS base coat down below that's already been installed. And then the EIFS, fully adhered EIFS system is going to be installed above this L-shaped through wall flashing. Looking at the image on the isometric on the right, you'll see just another condition of that. So we have our sheathing board back here. This yellow indicates the WRB. These vertical ribbons are the adhesive for the insulation. And you'll see the WRB laps over the vertical leg with a joint treatment here. And then water running down this WRB would be exhausted out of the bottom of the system with that through wall flashing. So some references that can be used and looked at here. The current building code for Honolulu, 2018 International Building Code, section 1407 references EIFS as a cladding. So In 2009, the IBC approved the EIFS as an exterior wall cladding. Prior to 2009, EIFS was not mentioned in the national codes and was considered an alternate material. The EIFS manufacturers obtained code approval at this time through issuance of the ICC evaluation reports, things like that. Other references that can be used that are pretty vital to the design and installation are the manufacturer's catalogs. As we talked about before, these are manufactured systems, and the information provided by those manufacturers is actually, there's some really great information, very specific in the installation and design, but the catalogs are provide a lot of great information. And then another reference is the EMA, so the East Industry Members Association. So for the actual insulation board, when we talk about how that's attached, there's two different ways to attach it. Similar to a roofing system, you could have a mechanical attachment, or you could have an adhered system. The mechanical attachment uses mechanical fasteners with plates, these large washers installed at a grid. The fastening pattern and the quantity of these fasteners needs to be provided by the manufacturer for whatever wind pressures and wind components and cladding numbers need to be met there. Another system is the fully adhered system. So this uses adhesive ribbons, which is the same material as the base coat, and that is installed on the back side of the board or the WRB, and the insulation board is placed up against it. The negative to using a mechanical system is that those fasteners, once they're installed, are puncturing the WRB. That creates several potential holes in your drainage plane, which can be a fairly big problem. We would recommend using an adhered system because it doesn't puncture the WRB, and you can also achieve higher wind uplift pressures, resistance pressures. So the adhered system is a very good system to use as long as it's installed correctly. We'll get into some issues with the ribbon adhesive installation and everything like that, but just something to keep in mind. As we get into some thoughts of the detailing, the EIFS material the standard details should not be modified. They can be made project specific, but as I'm going to keep hitting on, these are manufactured systems, and the typical details that are just the system alone should be done per the manufacturer's specifications and system instructions. Where the tricky part of the design comes in is, like a lot of systems, is at the interface conditions. So where there's interfaces at roof or wall conditions, or adjacent wall systems or windows or things like that. So here you see an image, an isometric, which is just showing the EIFS isn't even showing here. This is just showing a wall to parapet condition. EIFS or roofing is down here. And this detail is just intended to show how a saddle flashing, fully soldered saddle flashing, is used along with the liquid applied WRB to integrate this drainage plane from the wall to the roof condition. So there's going to be a parapet coping here. The EIFS is going to be installed over this, but behind all that, where we have the drainage plane, it's vital to make sure those components are all tied together. In the details, we also like to, in the design, we also like to just include what the system is. So I'm going to go over it just one more time here. So this typical system includes, we have our stud wall backup, our wall shaving, This dark gray hatch indicates the WRB. The vertical ribbons are the adhesive for the insulation board. And then we have our reinforcing mesh that's fully encapsulated in the base coat. And then our finish coat on top of that. So if you look at it just in a typical detail section here, you can kind of see each of those components. Once, some things to note during the design that are industry standards, but are often still missed quite often during the installation, is some typical detailing considerations. So just going down this list, we have back wrapped end conditions. So that's where the reinforcing, so at openings or at end conditions, base of walls, top of walls, that interfaces with windows or doors and openings, the EIFS is supposed to be back wrapped and pre-back wrapped. And that means the reinforcing mesh that's fully encapsulated in the base coat is supposed to be wrapped around the end of the board, similar to this orange J here, and installed. So this is to help provide robustness and strength and prevent cracking at these potentially weak areas around the rough openings. So this pre-back wrap condition is very important for the installer to do. And if they get lazy or just forget, they won't have this J-shaped pattern. They might just install this insulation board and then shoot, I need to install the base coat and reinforcing mesh, and it'll be an L shape here, and it won't wrap around, and then the system will become much weaker and much more susceptible to cracking. Again, this is a standard, an industry standard detail that would be important for the warranty of this system. So another item that's an industry standard, but often missed, is that the sealant, so let's say we're talking about at base of all conditions, top of all conditions, at windows or doors, needs to be applied to the base coat. It's not to be applied to the finish coat, as the sealant will not perform as intended if it's applied to the finish coat. So to get the intended service life of the sealant, it needs to be applied to the base coat. This detail shows that by indicating where the finish coat is, and then the finish coat stops short of where the sealant is, and the sealant's applied either before or after, and the finish coat stops short. You can see that the sealant is applied to the base coat, not to the finish coat. L-shaped corners, L-shaped insulation boards at corners. So instead of just, we'll include I have an elevation showing that pattern later, but the corners of either window or door or different wall planes, the corners are very susceptible to cracking. So to help reinforce the system at those corners, there's a few ways to do that. Number one, you're supposed to use L-shaped boards at the corners. And number two, you're supposed to use that butterfly reinforcement at the corners. This is along with the back wrapping at those openings. And then I'm going to keep hitting on this. I talk about the vertical adhesive ribbons. So those vertical adhesive ribbons are vital because they're applied to the WRB, which is the drainage plane. So if water gets down there, the ribbons need to be installed in a vertical manner to allow for the drainage. If they're installed in a horizontal manner, then any water that gets through will essentially hit dam after dam and just be blocked. And then it will travel laterally, which can create some problems and maybe be a condition that's susceptible to water intrusion. So it seems like a pretty typical thing to say and a pretty logical thing to say, but often installers might just have a lapse in judgment and install the boards with horizontal ribbons. So that's something to definitely specify and keep an eye out for. Another thing is the importance of these expansion joints. So when you're designing this, you need to determine where you want the expansion joints or joints in the EIFS system to be. So these joints would be a sealant joint that's separating the EIFS board joints. Typical locations for these sealant joints, would be at building expansion joints. Obviously, if the building has an expansion joint, you want that to translate through the EIFS cladding. Otherwise, you will get substantial cracking because you need to allow for that movement of the building expansion joint in the cladding. Other locations for sealant joints would be around perimeters of windows, doors, scuppers, and fixed attachments. If there's a change in the substrate, that's likely going to have differential movement. It's important to include a joint at those locations to also allow for that movement. And then if there's a multi-story wood frame construction, you need to include a joint at the horizontal locations. Shown on the picture on the right, it's important to include a joint at the floor line if there's deflection tracks. So those deflection tracks obviously allow for the deflection and movement of the floor above, and to since our EIFS is adhered to both areas, it's important to include that sealant joint to allow for that movement. And also if there's changes in building height. Again, I'm sure you know that EIFS is really susceptible to cracking, and any way we can design and build this cladding to accommodate or to minimize that cracking, the better the system will be. One other thing to consider is this reinforcing mesh. So there's different types of reinforcing meshes that have different thicknesses. So the ASTM 2486 establishes the 4 impact resistance classifications. So they have standard, medium, high, and ultra high. And when it says impact resistance, that's literally impact resistance. Someone bumping into it, someone trying to maybe puncture it mechanically or something like that. It's recommended that high or ultra high impact be used within 8 foot of grade and at high traffic areas. As you can imagine, you have this thin layer of base coat and finish coat with this reinforcing mesh here. It wouldn't take much to penetrate that base coat and finish coat. So at these high traffic areas, this upping the impact resistance of these reinforced meshes and upping the strength of those would really help address potential impact and damage at those areas. So here's an elevation. I was talking about kind of a board. This is a shop drawing, or this is a detail of a board layout. And when I talked about those L-shaped corners, so this is just a normal window opening, and this shows the grid around this perimeter shows how there would be a back wrapped. The boards would be back wrapped around the opening here. These sections around each of the corners show the L-shaped configuration that the board should have. So the insulation board, as is put in, needs to be notched out to form an L shape, and instead of having 2 rectangular pieces forming and meeting at this corner. If that happens, a crack will likely form. A diagonal crack will form protruding out of these corners. And then you'll notice this butterfly, this corner reinforcing mesh, also just used to reinforce the corner and help prevent that cracking. Another concept to consider is the detailing at a windowsill, and one option to include at the windowsill detailing would be the addition of a sill pan. So if you have a punch window opening or a storefront system, something like that, you could include a sheet metal sill pan or something done with liquid flashing to help direct water away from the windowsill and out of the rough opening of the wall. some of the benefits are you have this back leg that prevents water from getting into the interior. And then it's also, it's important to include a fully sealed or fully soldered end dam that can be integrated with the WRB at the rough opening. So as shown here, water that's traveling down the jam or water that's hit the horizontal portion of the sill flashing will be sloped and directed towards the exterior. Just something else to note, I'm going to keep pounding on it. You'll see the back wrap, this upside down J shape here, indicating that the back wrap condition at the terminating edge, and then you'll see the sealant is applied with these graphics. The sealant's applied to the base coat here, and the finish coat stops short of that sealant joint. This is just another detail showing an option for a windowsill and how that's integrated with EIFS flashing. This one shows a two-piece windowsill. This was used on a project in Nashville where they wanted to prevent thermal bridging, so they didn't want to run one piece of they didn't want to run one sheet metal L flashing from the inside to outside, because during the colder months they can get some condensation on issues on the interior face of that sheet metal flashing. So they want to create a thermal break in that, and so they use two different pieces. So we use an L-shaped sheet metal pre-finished aluminum piece here, and then a preformed silicone to lap over the WRB on the wall surface, and then to provide a durable and continuous sealing surface for the EIFS and to protect the top edge of the EIFS. We added another kind of U-shaped sheet metal coping section there, or sheet metal flashing section. When we look at door and window head conditions, we'd recommend you also using a through wall flashing to help direct water away from the rough opening in the top of the window or door system. So as you look at it, you'll see, water coming down the drainage plane will be traveling down approximately where these blue arrows are. And that WRB is lapped over the vertical leg of the through wall flashing and then directed out. We included a sealant joint there with weeps installed at 24 inches to allow for drainage. Again, you'll notice the sealant is applied to the base coat. The finish coat stops right at this strip edge. You'll notice this piece shows the back wrapped desired installation. Just some other things to keep in mind is that horizontal surfaces of EIFS need to be sloped a minimum of 612 or 1 to 2. So over time, this has been revised and made more stringent, essentially increase the slope because of the susceptibility of EIFS in a skyward facing manner. So at window sills and things like that, it can't be used as a parapet, as a material for a parapet, and it's just not made for that. So where it is used, and it's used in a horizontal application, it needs to be sloped 612, or it can be covered with sheet metal. If it is used and it's not covered with sheet metal, it's sloped 612, then there's some special materials, special application for the finished materials that'll be needed per the manufacturer's instructions to satisfy the warranty. So it'll kind of just make that horizontal surface more robust, more resistant to potential cracking and water intrusion. We find that the shop drawings are a very vital part of the EIFS specification. So in the shop drawings for these specs, we like to include, they need to show us the plans, the elevation sections. They need to give us actual project details of the components, not just the standard stuff, not just our details that are in the drawing set put on a shop drawing sheet. They need to work with the manufacturer and show these lists of components. They need to show how they're going to detail the penetrations and the terminations that are on the project. They need to show how the flashing of the, how flashing details are going to be done. So that's with the EIFS to the finish coat, or the EIFS to the WRB and the interface with the adjoining systems. They need to provide where the joint locations are going to be and the configurations, and then how it's going to be fastened or anchored and the spacing on those ribbons or fasteners. Another item I like to include on the shop drawings is to have that show a board layout. So similar to what we had for that single window, they need to show how the boards are going to lay out. That'll provide an understanding that they know what they'll be doing, and that'll provide some literature that they can look at during the installation, and that as a designer, when you're making your site visits, you can refer to if need be. Another vital thing is that EIFS can't, we found that a great or good installation of E-System is only done by experienced and trained and approved applicators. And I know that's applicable to a lot of different systems, but this is definitely applicable to installing EIFS. There are so many components and so many system specific details that are needed here that you really need someone who's done it before, because there's some concepts that might be missed, which can then become very problematic. So such as if things aren't back wrapped and you come out and they've already done a whole wall with a lot of window openings, then they would need to satisfy the construction documents, they would need to tear out all of the EIFS around the openings to pre-back wrap those insulation boards. So if they've installed horizontal ribbons or they installed the vertical adhesives improperly, then all of the EIFS would need to come off. And then you have an issue where you may damage the WRB behind, and then it just kind of unzips a lot of the work that's been done. Unfortunately, we've seen this on quite a bit of projects, and we found that these mock-ups, we found that in-field mock-ups or mock-ups ahead of the installation are really vital to make sure everyone is on the same page. Sometimes the installers, you often get, I've been doing this for 20, I've been doing this for 30 years, and then they'll install it wrong, or they're an EIFS installer, that's all they do, and the installation won't be per contract documents, and it also won't be per the manufacturer's instructions. So per most assembly installations, I found that that mock-up and using some experienced and trained and approved applicators, obviously the system is really important to the success of the project. There's a million things that go into the specifications, but just touching on a few, within the air moisture barrier is often part of the E system, so that can be included in the E specification. With that air moisture barrier, it talks about how you're going to treat the rough openings and the sheathing joints and inside and outside corners and spot fastener locations. There's specific instructions on all of those, whether using a joint compound or a separate flashing material, a separate liquid material. It's just important to specify exactly what the material is and how it's to be executed. Some other items to include in the specifications is the desired texture finish and the color, obviously. Talk about in the execution section of the spec, the back wrapping and the adhesive application. I'm going to keep hounding this because I've seen it on many times, and if you've gone out and you've seen EIFS installations, I'm sure that you have seen these issues before. What I like to include in the specs is to have the contractor remove one board per day or per 500 square feet. So They install it, and then you ask them to remove it, they take it off, and you look at the ribbons, so you make sure the ribbons are installed vertically. You're making sure that they didn't press the board too tightly against the substrate to smash the ribbons where they bleed out and then create a dam in that drainage channel. And then you're also making sure that instead of those vertical ribbons, they're not using little patties, which has been seen before. And then also how you want them to sliver and rasp. So they're per the typical manufacturer's instructions, there's not supposed to be any board joints that are greater than a 16th inch. Those need to be filled with, they can be filled with slivers of the EPS boards, or they can be filled with an approved spray polyurethane foam or something like that. But if there's cracks in the boards, so similar to what's seen here, that are over 16th inch, they need to be addressed. That's important to note in the specification. And there's also some rasping requirements to meet the manufacturer's instructions. The EPS board is, when it's exposed to sunlight, it can develop this powdery residue on the surface. And that residue needs to be removed by rasping prior to the application of the base coat and reinforcing mesh. That's an important piece. There's also certain provisions for UV exposure, extended UV exposure for these insulation boards. So something to keep in mind if it's been outside and exposed to UV for a long time. This is the last item that I would touch base on is this is vital, and you have to specify and the installer has to include a single source system. So one source or approved materials that are compatible with the system for the entirety of the system. So they shouldn't be using drive-it components with a stow system or something like that. Unfortunately, we see this all the time. I don't know if the installers have some extra material in the shop, or they think kind of one size fits all. A base coat's a base coat, mesh is a mesh, but that's not quite the case. So when you're out on site, I would definitely document and check this, definitely include in the specs. If we allow components from different manufacturers to be introduced, they're not part of the tested system. Therefore, there could be some compatibility issues, some failure of the systems, and you could void the warranty. And it might not be a fire tested system, so it could eventually become a life safety issue. Definitely be aware of that. For these single sources, there's different colors of components. So when you're out there, so certain manufacturers have different color reinforcing meshes. So just be aware when you're making your site visits to know what you're looking for and making sure that's what's actually being installed on site. Then we're going to jump through a couple pictures here, going into kind of the installation and some potential issues. So on the right, you'll see this is just a screw fastener through the base coat. We want that base coat to be continuous. It's eventually going to be covered by a finish coat, but prior to that finish coat installation, you want to address these fastener holes. And then the image on the right, you'll see that the liquid applied WRB is too thin. You can see the stamp of the wall sheathing board, and then especially right here, you can almost see it's down to nothing. That liquid WRB is often not a reinforced material, but there is a certain wet mill and dry mill thickness that it needs to achieve to properly be properly service the WRB. So as we talked about, The image on the left here shows gaps that are bigger than 1/8 of an inch. As we mentioned before, anything bigger than a 16th inch needs to be filled with slivers or a spray foam, approved spray foam. And then the image on the right shows application where there was a joint in the insulation boards that was filled with, this looks like it was filled with base coat. You can see it here between the insulation boards and right here in sections where we created inspection opening. And you'll note right along that joint, there's a crack that had formed. Another condition that we see, unfortunately see a lot is unsealed or failed sealant at penetrations or openings. So the image on the left shows EIFS installed very tightly to a dryer vent wall penetration. And I mean, there's not even room for a proper profile of sealant joints. So a few things here is the EIFS should have been set back and the perimeter sealant joints should have been installed. Something to consider. The image on the right shows a proper detailing of that kind of system. And you'll see, so we have the yellow WRB, we have the transition material to this scupper sleeve. So it's sealed at the drainage plane. And then on the exterior, we have this perimeter sealant joint around the outlet of the scupper. And we get into the installation. So as I previously mentioned, the base coat is to fully encapsulate the reinforcing mesh. So if you ever go out and you see the grid pattern of the reinforcing, they need to install more base coat because it needs to be fully encapsulated. So here's a condition where, okay, we see the base coat, but at these conditions, they got a little sloppy, they need to add more material. This is a finish condition where the underside, where they hopefully pre-back wrapped this condition right above at a window head. You'll see they didn't fully encapsulate. You see that reinforcing mesh coming through. And then, yeah, this just shows, again, this is just a window head condition, and you'll see, you know, that's shown that full reinforcement is noted in the specifications, it's noted in the manufacturer installation instructions. It's also indicated here where this dashed line indicates reinforced mesh, and then you show this base coat as a thick material that fully encapsulates that reinforcement mesh. And then that's some false joints. False joints are fine. They're the reveals or something of that nature to provide a break, but they're not a sealant joint that allows for movement. It's just a reveal. And cracks can form in that reveal. That's fine. When you do that, you're lessening the thickness of the insulation board. And it's important to consider that at a minimum, the insulation always needs to be 3/4 inches thick. Otherwise, there's a really high likelihood that the cracks will form at those spots. And then just the high stress areas of a typical design. So as I mentioned before, the corners of openings are high stress areas. And we talked about those L-shaped boards, the pre-back wrapping and the butterfly mesh at these corners. None of that was used at this location, along with there was no exterior joints. So you'll see that at each of these locations, cracks are coming off of the upper and lower corners from these wall penetrations. Even the dryer vent coming off there, on top of the window, and then at the bottom of the roof here too. And then also a lack of joints. So these are this is a 2-story single-family dwelling. They didn't have any joints to allow for movement of the material, and so the laminate moved on its own, and just cracks started forming vertically and horizontally. At this for this application, joints should have at least been. This is a wood frame construction, should at least been put at the floor line, but based on the size, it would have been good to include vertical and horizontal joints to allow for that movement of the boards to try to limit the insulation. This is also an application that was used as a barrier system. So all of these cracks allow water to get through and behind the lamina, behind the insulation board, between the insulation board and the sheathing. And that all of these cracks can lead to water intrusion, because there's no way for, once water gets within that system, there's no proper way to drain that water out of the system. So it becomes trapped and eventually needs to find its way out, or the path of least resistance, which might be leak on the inside. And then here's finish coat insulation. So this is showing, this is the colored finish coat. It's not that gray base coat that we were seeing in our spot. This shows the finish coat before the sealant joint was installed. Above this through wall flashing, you can see the finish coat comes all the way down and returns all the way in. It didn't stop short to allow that this sealant joint is to be installed to the base coat. So some remedial work needed to be performed here. And then lack of pre-back wrapping. So I touched base on it a lot. It's just a big issue that is missed quite often. So you'll see that this J-shaped pre-back wrapping here. It's kind of tough to see with a scaffold leg here, but you can see a pre-back wrap board. You would be able to see if you're doing a site investigation that it's pre-back wrap. They should have put this J shape on as they installed the board, so you'd be able to see the base coat at least, and the fully embedded mesh coming around from the corner of the opening. So if that's not there, and you just see a white an exposed insulation board abutting the opening, you know that's not pre-back wrap. You have to remove and replace that piece. And that kind of wraps it up. So just some important things to consider is selection of the proper system, whether you want a barrier or a drainage system like we'd recommend. The selection of specification and site observation of a single source manufacturer for the system. It's obviously important, as we know, to how are we detailing the cladding or our system with the adjoining systems, whether they're horizontal or vertical systems. And then yeah, just there's important to know the typical problematic conditions and how to identify them and how to resolve them, hopefully before or during construction. Because once you get to after construction, it gets a lot messier and a lot more costly, extreme. So that's all I have for now. Thank you very much for attending. Does anyone have any questions?
Where are those details?
Say it again.
Are the details that you showed in the presentation available online somewhere?
A lot of those are my project details, but if you go to the manufacturer's websites, so a lot of the isometrics that were there are from manufacturers' booklets. So there's different manufacturers, Stowe, Drive It, things like that. They have booklets, electronic booklets showing so many different variations for so many different types of details. So they give you a lot of options. They're actually really exceptional in my mind. Some need to be tweaked a little bit to make specific for your project, but I think those are excellent references. The exact details where, you know, showing window or head conditions or something like that, that were in section and not isometric, those are just details that I pulled from different projects.
Okay, awesome. Thank you so much. All right, anybody else have any questions? Okay, then. Thank you so much, Dustin, for the presentation. We really appreciate it. And thank you everyone for joining us today. And this is an AIA approved presentation, so you'll be getting credit within a couple of weeks. Thank you. Have a wonderful day.
Thanks, guys.